Hello everyone, my name is Megha Arti. I am doing this internship based on the embedded system, and during this internship I built the project based on the MPLab X IDE, which is simulated on the software named PixinLab. We work on this project, that is microwave oven simulation. Okay, now let us begin. These are the contents we are covering in this. That is, first one is introduction to C programming, introduction to embedded system, next the categories of embedded system and the components of an embedded system and the requirements of the embedded system, and last one the project implementation, that is the micro oven. Okay, let us begin the introduction to the C programming. Now, what do you mean by C? C, that is a general purpose procedural programming language. The history, like it is developed by Dennis Ritchie in 1972. Where we can use the C programming language, like it is used in system programming, embedded system or the game development, etc. The future sees it is the fast, portable, modular and efficient. Okay, next one. Okay, this is the basic syntax and the data types. The structure of a C program, like okay, this is the standard header file which is used in the C, that is hash include standard input output dot h, that is stdio dot h, and this is the main function. Okay, data types which are used in C is int, float, char, double, void, etc. Okay, the variables and the constant declaration, initialization, and next one is the input output, where printf, it is used to print the statement. The scanf, it will read the input, like if we enter the printf, like enter the set of numbers, then it will scan like percentage %d, comma ampersand of num, like it will read the input. Okay, next is control statement in the C. Like control statement, it manages the flow of a program, like it by making the decisions it will control based on repeated actions. Okay, first control statement is if statement and else if statement, switch case statement. Okay, these are the control statements, and again different is there, I just included three. Okay, if statement, like it executes a block if the condition is true. Like if statement, it will execute the set of block is there. Now, if the condition is true, it will execute. Then if else statement, like it adds an alternate block if the condition is false. And next switch case statement, like it consists of multiple case statement. It used for multiple, for if we consist of the multiple condition, the best way approach condition statement is switch statement, like we can include in all the case with the case labels. Okay, let us consider one example, that is int num is equal to 10. If num is greater than 0, then printf positive number, else printf negative number. Here you can see that num is equal to 10, which is a positive number. So if num it is greater than 0, right, num, then it will print this, print positive number is printed. Okay, next we go through the loops. Loops, it is used to repeat a block of the code multiple times. The loops is used to repeat the block of the code multiple times. In order to repeat multiple times, the loops are used. Okay, for loop, first there are three types of the loop. One is for loop, while loop, do while loop. The for loop, it is used when the number of iterations is known. When we know the iteration, like it consists of initialization, incrementation, initialization, declaration, implementation. If we know the number of iteration, then the for loop is used. Next one is the while loop. It executes while a condition is true. It executes when the condition is true. Next one is do while loop. It runs at least once, then if repeats if the condition is true. Okay. Next we go through the functions and the arrays. What is function? A function is a block of code that performs a specific task. Like it is the block of the code which performs a specific task. It can be called as multiple times throughout the program. Okay. Okay, there are the three types of the function, which is the built-in function, user-defined function, recursive function. What do you mean by built-in function? The built-in function is nothing but it is already inbuilt itself in the C. It is provided by the C itself, like printf, scanf. It is already built in, right? So in that, then user-defined is nothing but it was created by the programmer itself, like to perform the specific task. It is not built in, it is created by the programmer. Okay. Next one is the recursive functions. It calls themselves in order to solve the problems in the smaller steps. Like example, calculating factorial. In that case, we are using the recursive function. Okay, next we go through the arrays. Okay, what do you mean by array? Like the array is a collection of elements of the same data, like type stored in the contiguous memory locations. Like it is the collection of the array. It is the collection of the same data elements, like set of the collection of the elements of the same data. Okay, there are the two types of the array. One is the one dimensional array and the multi-dimensional array. First one is a one dimensional array. It is a simple list of the elements. And next one, multi-dimensional array, an array with the multiple levels. If it is there, then it is called as the name multi-dimensional array. Example is a 2D array. That okay. Next we go through the pointers and the structures. Okay, let us consider the basics of the pointers. Okay, let us see. What do you mean by pointer? As you know that a pointer is a variable that stores the memory address of another variable. Like pointer, it is one variable. It stores the memory address of the another variable. Okay, let us consider example later. First we go through the syntax. Syntax is the data type. It can be int, float, etc. And this is asterisk, star, then the pointer name. You can give any name. Okay, let us consider the example. First, int a is equal to 10, initializing. It is the data type which you are used is int. So int a is equal to 10. Then int star pointer, it is defined ptr is equal to, it stores the address of a. So now what is the output of this? It is nothing but 10 because it stores the address. Address of a is nothing, 10. Okay. Next we can go through the structures. What do you mean by structure? A structure is a user-defined data type that groups the different data types. It will group the different data types. It will group together. Okay. Example is struct student. It character name. Like you can give your name. Then it is names, alphabets. It is described in the form of char. Character name of 20. Then int age. And okay, this is the example for the struct. Okay. Next, our C programming is done, basic concepts. Next, we can go through the introduction to the embedded system. Okay. Now, what do you mean by embedded system? The embedded system is nothing but it is the combination of both the hardware and the software. Okay. Let us go through the definition. Okay. The embedded system is a computer designed to perform a specific task or the function within a large system. Okay. It is the combination of hardware and the software in order to perform the specific task. Okay, let us consider the examples of the embedded system. It is used in these applications like home applications. It is used in washing machine, microwave oven. This is in this we are doing project. Okay, next one is the refrigerators. Next we go through the automotive system, that is anti-lock braking system and the airbag system. Airbag. Next is the consumer electronics, like it is used in the electronics like smart TVs, wearable device, so on. Next, medical device, it is used in pacemakers, ECG machines, etc. Next, industrial automations, it is used in robotics, programmable logic controllers, PLCs, etc. Okay, understood. Okay, next we go through the categories of the embedded system. Okay, there are the 4 different categories. One is the standalone embedded system, real-time embedded system, networked embedded system, Next one is the mobile embedded system. First one is the standalone embedded system. Is nothing but it operates independently without the need for the host. It operates as independent without the need of the host, like digital cameras, micro ovens. Examples. These are the examples. Okay, next one is the real-time embedded system. It is designed to respond to inputs within a certain time frame. Within a certain time, as the name suggests, real time. Within a certain time, it is developed. Example is that is airbag system, flight control system. Okay, let in the airbag system, let us consider the example. If the accident is going to happen, then the airbag will open, right, at the particular time, in the real time. At that it is used in the real time, like that. Okay, next one is a networked embedded system. That is the it communicates over a network. As a network, it is used for communicating over the network. Example is smartphone device, smartphone. Next, industrial control systems, etc. Okay, next last is mobile embedded system. Mobile embedded system is nothing but it is embedded in the portable device. Mobile, it is nothing but portable device, right? So it is embedded in the portable device. Example, smartphones and smartphones. Okay. Okay, next we go through the main important topic, that is the components of an embedded system. That is the components of the embedded system. Okay. These are this is there, no microcontroller, system on chip, microprocessor. This is the main component. Okay, it is also called as the brain of the system. It is used for it process the data and makes the decisions. Okay, these are the inputs, sensors and the analog to digital counter converter, analog to digital converter, and this one is the sensor. These are the input device. Like sensors, it collect the real world data, like temperature. It will sense the temperature which is in the analog form. In order to convert it into digital form, we are using the analog to digital converter. And next we have the process storage. It will process storage, like storage, it will use to save memory location, right? The memory location, store the memory we are using. Next, if advanced processing is needed, it may be send advanced for the advanced processing, it may be send data to the FPGA, that is nothing but field programmable gate array, or ASIC, that is application specific integrated circuit. Okay, this is input. Next we go through the output. It is output, that is actuators and DAC. DAC is nothing but digital to the analog converter. Based on the processed input, the microcontroller may need to control the actuators, example motors, etc. If the actuator requires the analog signal, then it converts as digital to analog. If it is in form of digital, then by using this, it is converted it into the analog. Okay. Next, it is the supporting system. These three are the supporting system, that is human interference, a diagnostic port, auxiliary system, and all. Human interference is these allows the user to interact. It will interact with the system, like button, touch screen, etc. And next one is the diagnostic port. It is used for debugging and troubleshooting. Okay, next one is the auxiliary system, which is provides the necessary power and cooling to ensure the proper software operation. Okay, next is the software. The entire system, it runs on the software that dictates how data is processed, stored and used to control the outputs. Okay, that is the components of the embedded system. Okay, next we go through the requirements of an embedded system. There are the 4 requirements, that is real-time operation, next low power consumption, reliability and stability, small size and compact design. First we go through the real-time operation. That is, many embedded systems are required to function in real time, right? Like airbag system. So the real-time operation is done. Next one is the lower power consumption. Systems are designed to operate on the limited power. To operate in the limited power, the lower power consumption, like battery operated devices, etc. Next, reliability and stability. It is nothing but embedded system must be dependable, especially in the critical applications. For the critical, what is critical application? Like in the medical devices. Okay. Next one is the small size and the compact design. It is the space constraint are common in many embedded system. Example is variable. Okay. Next we go through the LED programming. LED interface, that is LED, are connected to the microcontroller PIC16F8778. This is the microcontroller we are using in our microwave oven project. Through the input output ports, that port B, port D. Next one is LED control, that is using input output pins. LEDs can be turned on or the off. Next, sourcing versus syncing. What do you mean by sourcing circuit? That is nothing but the microcontroller provides the current to turn the LED on. Next, syncing circuit is nothing but the microcontroller grounds the pin to turn the LED on. Okay. Next we go through the switches and the interferencing with the microcontroller. Switches. Okay. First one is the switch interference. What do you mean by switch? That is, tactile switches are used to detect the user input. Connection is typically a pull up or pull down resistor is used. What do you mean by pull up circuit? That is nothing but the switch is connected to the ground and the pin is connected to VCC. Okay, what do you mean by pull down circuit? That is, in this case it will be a reverse, that is the switch is connected to the VCC and the pin is grounded. Okay, next we go through the switch detection. There are two types, level triggering and edge triggering. What do you mean by level triggering? The task is triggered based on the level of the switch. Edge triggering is nothing but the task is triggered based on the change in the state. Okay, next we go through the matrix keypad. Matrix keypad. Okay. What do you mean by matrix keypad? A matrix keypad is an array of keys arranged in the rows and the columns. Okay, rows and the columns, like it is each key is accessed by the scanning rows and the columns. Input output pins is a microcontroller uses its input output pin to scan the matrix. Okay, next is interrupts in embedded system. Interrupts allows the microcontroller to respond to the asynchronous events. Okay, what are the types of interrupts? External interrupts and the timer interrupts. External interrupts is triggered by external events like button press. Timer interrupts is triggered by the timer overflows. Next one is the timers and the timer 2. Okay, what do timers? What is the purpose? The timers can manage the time related functions such as the cooking time. Usages, it is used in it can be set to trigger after specific intervals to update the display of the heating cycle. Okay, next one is the CLC theory for microwave. For our project, we are implementing the CLCD theory. That is nothing but a character LCD in the microwave oven project is used to display critical information such as cooking time, temperature, and other user input settings. What is the purpose of this in the micro oven is it is used to display the timer countdown while cooking and show the temperature settings or the status messages. Example like cooking, paused and all. Next, it provides the error messages or the system feedback. Okay. At last, we can go through our project implementation, that is the micro oven project. Okay. Host, it consists of two types, host and the target. Host is nothing but we are using MP lab ID, right, in order to write the program. Next, target, the simulator we are using is PicSim lab and the board we are using is PicGenius, and the controller, this is the main, that is PIC16F8778. Okay, let us see the peripherals which is required for a project, that is switches, timer, CLCD, buzzer, fan. These are the 5 peripherals we are using in our project. Okay, let us start. Okay, let us open the micro oven. Okay. As you can see that it consists of header files and the source files. In order to write the header files, it consists of in the extension .h, clcd.h, main.h, matrix keypad.h, microoven.h and so on. And the source file, it consists in the extension .c, that is clcd.c, ISR. These are the programs we are writing. Okay. Now let us implement our project. Right click on the micro oven and clean and build. Okay, if we clean and build, it should display as build successful. Okay, our project is builded successful. Now let us open the Pixim lab. Okay, let us implement, now start to implement the micro project. Okay, now we have to load the X file, like we are writing the program in MPLAB XCD, right? So we are writing in the book, so we are implementing in Pixim lab. So load hex file. Okay, 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 open microoven.x, sorry, then go to delist, default, production, next click on open. Okay, once you open, it displays the messages powering on micro oven. After powering on, it will allow you to choose the 4 mode, that is micro mode, grill mode, convention and the start mode. Okay, when you click on micro mode, it shows power is equal to 900 watt. In the micro mode, it is showing that how much power is being used, and it will allow you to set the time, like it is time, it is playing, it will allow, like it is displayed in the minutes and this is the seconds, so you have to display the time. I will set time as 15 seconds. Okay, I will fill here seconds. So here I will, star is used for clear, here hash is used to enter. So I will enter, now I entered the 15 second and I will click on hash. Okay, when I click on the hash, the fan, it starts to rotate. It again consists of the 3 options: start or the resume, pause and stop. Once it is finished, it display the messages enjoy your meal. Next again come back to the same mode which is the main screen. Okay, then you can choose the grill mode by using the option 2. Okay, in the grill mode, there you can again see, you can again enter the time in the terms of minutes and seconds. Here I will enter the time in terms of the seconds, and here again contain the option of star, which is used to clear, and the hash used to enter. So now I will enter the times in terms of seconds. Then I will click on enter. Again, it consists of the different option, that is, it is used to start, it is used to pause. If you pause, stop, it will pause, right? Then 6 is to stop. Okay, option 6 is to stop. Okay, if you want to start, you can click again on 4. Okay, once you click on the 4, it will start to rotate. After it, again come back to the main screen. Next mode is convention mode. Okay, in the convention mode, you click on 3. In the convention mode, it will allow you to set the temperature with the time. So here I will set the time as 1:23. If I press the hash, it will down counter, like it will preheating it, like it shows the time remaining, that is 0:50. For the 1 second, it is terms of second, right? For the 1 second, it will preheating it. Here we are just setting the time, like here, but here we are not implementing any heater, we are just setting the time over here. Okay, 35 seconds, like it is preheating, remaining seconds it is displaying here. Once it comes back to the 0 second, again it will ask you to set the time. Let us wait. 14 seconds, 13. Okay. Once it is came, you can also enter in terms of the minutes and seconds. Okay, this is the, again it comes back to the same position. Here we can also set the time as okay. Once you set the time, click on hash. Again the microoven will start indicating the pan. Again 4 options will have the start, pause and the stop. Okay, you can pause, click on 5, you can resume, click on 4, or you can stop. Once you stop, click on stop, you come back, it will come back to the main mode, that is convention mode. Therefore, it will start the microwave with the default 30 seconds. It will keep adding the 30 seconds to your cooking time. Okay. Okay. It will cooking for default 30 seconds. You can also add the time mode. Okay. These are the 4 different types of the mode which we are implemented in our microoven project. Okay, it consists of again 4 mode: micro mode, grill mode, convention mode and the start mode. These are the 4 different mode, and this is the LED. How many LED consists? 1 2 3 4 5 6 7 8. Okay, total it consists of 16 LED, and this is the switch button, this is the display, and this is the PIC 16F877, and this is the fan, and this is the 4 types of the mode. Okay, thank you.